Hey, this is the second try. I just recorded this lesson without any volume, so hopefully you can hear me now. We are on page 329, and we are looking at lesson 5.1, the title of which is Solving Systems. Here's a new word for us. Systems of equations. And we're going to use the strategy by graphing. So we're good at graphing. We just got done with chapter 4. Everything's good to go. So when we look at a system of equations, we are trying to find the solution. The solution is the point of intersection. In other words, where they cross. If I drew a quick picture of you, no, I can't draw pictures of you. If I drew a quick picture for you, it would look something like this. Line 1, line 2, and this would be our solution, roughly over 1 up 2. The point 1, 2 would be our solution. Okay? So with that in mind, we're going to go on to this first concept. In example 1, it says, is this the solution to this system? Well, we just said if the two lines intersect at that point, then that's the solution. But what does that mean? What that means is this point lies on this line and on this line at the same time. And what that means is this x and this y make both equations true at the same time. So let's look at that. We're going to take our x and our y value. In the first equation, that's going to look like this. We're going to replace x with 4. And we're going to replace y with 1. We got those straight out of the ordered pair. And we're going to check to see if that equals 6. 4 plus 2 equals 6. It works for the first one. In order to be the solution to the system, though, it has to work for the second one. So instead of x minus y, we're going to have our replacements. 4 minus 1. Simply took those from the ordered pair. Does that equal 3? It does. It works in both, so we say yes, this is the solution. Okay? Well, what's it look like if it doesn't work? Example 1, part B, says, is this the ordered pair? Is this the solution where these two lines intersect? And our two lines are 5x plus y equals 8. And 3x minus 2y equals 5. So we're going to take our ordered pair, x and y, and substitute them in. Let's go ahead and do that. So instead of x right here, we're going to replace that with -1. And instead of y right here, we're going to replace that with 2, and we see that's 5 times y, so it's 5 times 2. We check that. We say -2 times 1, that's -2, plus 10, yep, that's 8. Well, it worked again. That's awesome. We're going to do the same thing for the second line. 3 times x. We're going to replace x with -1 again, and we're going to replace y with 2. And we're trying to see if that equals 5. -3 minus 4 equals -7. It does not equal -5. This is not the solution. Sorry, I shouldn't have done that. This is the solution. So we would say this. In order to show our complete answer, we would say this does not equal -5. Therefore, this is not the solution. Awesome. You guys try check it out, 1A and 1B, and show one of the teachers in the room your solution so that you can get checked off for that. Let's go ahead and take a look at example 2. Example 2 says, so this time, instead of them giving us the solution, we are going to graph the line. So example 2, part A, says, let's graph the system y equals x minus 3 and y equals negative x minus 1. We're going to graph the system and find the solution. So we can see that first line, let's go ahead and put that in red. This guy is red. We're going to focus on this. The y-intercept, negative 3. We're going to plot that point right down here, 0, negative 3. And then I want to use our slope. There's a 1 in front of that x. We know that is 1 over 1. So we're going to go up 1 over 1 and fill in several points for that line. That was supposed to be a red line, wasn't it? So we're going to go ahead and plot those points. Then we're going to graph the blue line. Blue line says we have a y-intercept of negative 1. So we're going to plot that point, negative 1. And then we're going to use, this is negative x, so let's rewrite that. That is negative 1 over 1. So that gives us directions. How do we get to the next point? We can go down 1 and then positive 1. Oh, and we found our point, haven't we? So the blue line comes down through here. The red line goes up through here. And we have found the location over 1, down 2. So that's positive 1, negative 2. That is our ordered pair, or our solution. If that is the ordered pair, then it's going to make both equations true. I'm going to replace the x with 1 and the y with negative 2. Negative 2 is equal to 1 minus 3. That's our first equation. Yes, it is. 1 minus 3 is negative 2. Does it work for the second one? When y is negative 2, does that equal negative 1, the opposite of x, minus 1? Yes, it does. We found our solution by graphing, and we check it into the equations. We have found our solution. You guys try, check it out. 2A and 2B, make sure you get some graph paper, and then show one of the teachers in the room what you come up with. At that point, you've got your ticket to move ahead and start on your assignment.